In question 15, we are given the Lewis dot diagram of methane, CH4, and asked which electrons are represented by the dots. So here we're dealing with carbon, element number 6, and hydrogen, element number 1. Recall that Lewis electron dots are always only going to be the valence electron dots. Now, we can look at this more looking at carbon. Carbon has a valence of 4. So carbon, the central atom, would have 4 dots, 1 dot per directional coordinate. And hydrogen has a valence of 1. So each hydrogen will give 1 valence electron. Now remember that atoms form bonds, whether they be ionic or covalent. They form bonds to obtain stable, noble gas electron configuration. Carbon here will have 8 electrons in its valence shell when it bonds with 4 hydrogens, and hydrogen will have 2 electrons in its valence shell. Recall, 8 is great, but 2 will do for hydrogen. Question number 16 asks, which of these elements will have the least attraction for electrons in a chemical bond? We will recall from last chapter that this is the exact definition of electronegativity. Electronegativity can be found on reference table S. Let's take a look. So we can simply look up the electronegativities, which I've already listed, of each of the elements. So oxygen, element number 8, has the electronegativity of 3.4. Nitrogen, element number 7, 3.0. Fluorine, element number 9, 4.0. And chlorine, element number 17, is 3.2. Notice we were looking for the least attraction for electron, or the least electronegative, so nitrogen is our best choice. The first practice question, we were asked about the bond between 2 bromine atoms in a bromine molecule. Here is bromine. Bromine is to the right of the bold zigzag staircase. So bromine is a nonmetal. When 2 nonmetals bond, they always form a covalent bond. Now, the definition of covalent, they coordinate or cooperate by sharing electrons. Question number 2 is review from our periodic table unit, and it asks the amount of energy required to remove the outermost electron from the gaseous atom in the ground state, and this is just a simple definition of first ionization energy. Question number 3 has us examine a data table. Notice the table has melting point, boiling point, and conductivity data. Ask which is an ionic bond. Now ionic bonds have high melting points and boiling points, and they conduct electricity only in the molten and aqueous states. The word aqueous also means in solution, so choice D would also be an ionic compound. Question number 4 asks about a chromium +3 ion. To examine this question, we need to look at the reference table. So chromium is element number 24. If we add together the numbers in the electron configuration, we see that a chromium atom normally has 24 electrons. Recall, though, from our atomic structure unit, that the charge of an ion is equal to the protons, the positives, minus the electrons. So here, if I have a charge of +3, then that is equal to the protons 24 minus the electrons. In this case, there must be 21 total electrons to solve this algebraic problem. Question number 5 asks us to locate the correct Lewis electron dot structure for a compound of magnesium fluoride. The first thing we have to do is investigate magnesium fluoride. Now magnesium is located here, atomic number 12. Magnesium is a metal, while fluorine, atomic number 9, is located here. It is a nonmetal. When metals and nonmetals from different sides of the periodic table bond, it's an ionic bond. Recall, ionic bonds are ironic bonds because they come from different neighborhoods and yet they still want to bond. So, ionic bonds will transfer their electrons. Since they're going to transfer their electrons, they need to have distinct structures. So, ionic Lewis dot structures have brackets showing the transfer of electrons. Choice 1 and choice 4 show covalent sharing of electrons, so those can be eliminated. Now, magnesium, found here, has a oxidation state of +2. That means that the magnesium ion wants to lose 2 electrons. And when we look at the structures, only one of the structures has magnesium with a +2. So this is the best choice. Now, notice that the sum of these charges also add to 0. Ionic bonds transfer electrons, they lose and gain electrons so that everybody can obtain stable noble gas electron configuration. Looking at the noble gases, notice how they have an oxidation state of 0. So the sums of the oxidation states of the compound must add to 0 so that they can have stable noble gas electron configuration. Question number 6 asks about the bond type when electrons are transferred. Electrons transferred is the simple definition of an ionic bond. Next, we're asked to look for the correct Lewis dot diagram. In order to do so, we should refer to our reference table. Recall that Lewis dot diagrams represent the number of dots in the valence or outermost electron shell. Nitrogen, whose electron configuration is 2,5, has a valence of 5. This nitrogen only has 4 dots, so this is not an appropriate structure. Fluorine has a valence of 7. So this structure has a valence of 8 dots, so this is not appropriate. Oxygen has a valence of 6. This structure has 7 dots. And lastly, neon has a valence of 8. So this is the correct Lewis dot diagram because it has 8 dots. The next question asks, what occurs when chlorine forms a chlorine ion? Now we'll refer to our reference table and we'll find chlorine. Chlorine is atomic number 17. Recall from the previous example that we have a formula that says that charge equals protons minus electrons. Now, chlorine, the ion, has a charge of -1. And chlorine's atomic number is 17. In order to accomplish this, that means that a chlorine ion must have 18 electrons. So if the atom has 17 electrons and the ion has 18 electrons, chlorine gains an electron. Now, whenever you gain anything, you always become larger. Think about gaining weight. The next question refers to chlorine forming a molecule. When chlorine forms a molecule, it forms a bond. We always know that atoms form bonds because together they can release energy. Next, we're looking for a particle that has the same electron configuration as a potassium ion. Potassium is found here on the reference table. We can see that the electron configuration for a potassium atom is 2, 8, 8, 1. But we can also see from our reference table that potassium has a charge of +1. Now that means that when the atom forms an ion, we can simply sum together these numbers, which will cause them to cancel out. And our new electron configuration will be 2, 8, 8. Now, looking on our periodic table for a species with the electron configuration 288. We can see that matches the electron configuration found here with the argon atom. Now a fluoride ion, fluoride has an electron configuration of 2, 7, but it has a charge of -1, meaning it gains an electron. So its electron configuration is 2, 8. So it has the same electron configuration as neon, the closest noble gas. A sodium ion has an electron configuration of 2, 8, 1 with a charge of +1, meaning it loses an electron. That means that sodium ion will have the same electron configuration as neon. And then neon has its own electron configuration, which does not match that of potassium ion. The next question, we were asked about the dots in the Lewis dot diagram of an atom of an element period 2. So here we have period 2, runs from lithium through to neon. And we know that Lewis dot structures are always equal to the number of valence electrons. Question 12 asks about the type of bond formed between two atoms of bromine. Bromine, element 35, is a nonmetal, and the type of bond formed between two nonmetals is always covalent. The next question is a question that will not be on our bonding exam, but will be on subsequent exams, and it asks, which bond is most polar? Here, the key term is bond and polar. Recall that the polarity of bonds is a function of the difference of electronegativity. The difference of electronegativity will have to be calculated using reference table S. Notice that all of these compounds contain hydrogen. Hydrogen has an electronegativity of 2.2. So we are going to find the difference of electronegativity from some number to 2.2, beginning with bromine. Bromine's electronegativity can be seen on atomic number 35, which is 3.0. So here we'll simply write down 3.0. Now, chlorine's electronegativity is 3.2, while fluorine is 4.0, and iodine is 2.7. That is element number 53 and is found on reference table S. Now, we're looking for the most polar bond, or the biggest difference in electronegativity between the electronegativity value we have written down and the electronegativity of hydrogen, which is 2.2. So we're looking for the absolute value of the difference, and we can see that the biggest difference here is fluorine. So HF is the most polar bond. Question number 14 asks, which contains metallic bonds? Metallic bonds must have a metal, and they must only have a metal. So we can look on our periodic table to identify metallic bonds. So here on the periodic table, we can see Hg, mercury, is indeed a metal. So this will have metallic bonds. Now, H2O contains two nonmetals, hydrogen and oxygen. Sodium chloride contains one metal and one nonmetal, making it an ionic bond. And glucose here contains carbon, hydrogen, and oxygen, all nonmetals, so no metallic bonds. The final question in this series asks, what are the total number of electrons in a copper ion? Finding copper on our reference table, element number 29, we recall the equation that the charge equals the protons minus the electrons. So the protons is the atomic number, which is 29. We are looking for the number of electrons. We see that this copper ion has a positive charge. If a simple positive is given, it actually means +1. The correct answer here would be 28. Question number 16 asks us the definition that we studied in our periodic table unit, which is the strength of an atom's attraction for electrons in a bond. That is the definition of electronegativity. Question number 17 shows us a fluorine atom gaining an electron. And so here we can see we have a charged particle. Charged particle is called an ion. So here we have the fluorine ion. The fluorine ion, because it gained an electron, will be larger. Notice that the fluorine atom has 7 electrons and the fluorine ion has 8, as represented by the dots in the Lewis dot structure. Now, the high electrical conductivity of metals is always due to mobile or moving electrons. Remember that metals have low valence numbers. They spit out their valence electrons, and they allow the valence electrons to essentially be delocalized, and they dance around in a Congo line style fashion around various metal ions so that they can temporarily have 8 valence electrons. Question number 19 is a great question that asks which of these will have the highest melting point. So recall that high melting point is a property of an ionic compound. And ionic compounds form between metals and nonmetals. So we'll need to refer to our reference table. So water is formed between hydrogen and oxygen, 2 nonmetals, making a covalent bond. So water is not ionic. Now sodium oxide, sodium is a metal and oxygen is a nonmetal, different sides of the bold staircase. So this is an ionic bond, so it will have a high melting point. Now sulfur dioxide, sulfur and oxygen, 2 nonmetals because they are on the same side of the staircase, as are carbon and oxygen, same side of the staircase. So those are all covalent bonds. Question number 20 shows the chemical test that a chemist did on the physical properties of 2 substances. Notice they have different properties. So one has a very high melting point, while the other has a low melting point. One tends to be very soluble in water, the other tends to be insoluble in water. One is a good conductor in an aqueous solution in water, and one does not conduct electricity in water. So these are very different, and we see that the properties of A make it like an ionic bond, the properties of B make it like a covalent bond. So the best choice here is choice 4. Question number 21 requires use of the reference table and asks which has the highest electronegativity. So notice we can find electronegativity here in this column. So let's write down what we discover. Hydrogen has an electronegativity of 2.2. Potassium has an electronegativity of 0.8. Aluminum has an electronegativity of 1.6. And calcium has an electronegativity of 1.0. Here we are looking for the highest electronegativity. So hydrogen is the correct answer. Now for question number 2, we are looking for an ionic compound. Recall that we can say that ionic compounds are ironic compounds because they contain metals and nonmetals. Now looking at sodium chloride, we'll find sodium, which is to the left of the bold zigzag staircase, making it a metal, and chlorine, which is to the right, making it a nonmetal, form an ionic bond. Now dinitrogen monoxide forms a covalent bond because nitrogen and oxygen are both nonmetals and they cooperate by sharing electrons. Hydrochloric acid contains hydrogen and chlorine, 2 nonmetals, again a covalent bond, and water contains hydrogen and oxygen, 2 nonmetals, again containing a covalent bond. Last of all, we are asked which of these species does not have a noble gas electron configuration. sodium ion plus 1 charge. Sodium atom usually has the electron configuration of 281. But when we have the positive 1 from the ion, taking this into account, the 1's cancel out, so it has a 2,8. 2,8 is the electron configuration of neon. Magnesium plus 2. Magnesium atoms have the electron configuration 282. But when it forms an ion, it has a plus 2 charge. So these electrons cancel each other out, and we're left with 2,8. Again, the same electron configuration of neon. Argon, element number 18, is a noble gas. It has an electron configuration of 288. And then sulfur, element number 16, has electron configuration of 286. The electron configuration of 286 is not found in group number 18, so this is not that of a noble gas. Question 24 was explained in question number 23. So a sodium atom has the electron configuration of 281, but its ion has a positive 1 charge. So these will cancel each other out, and it will have an electron configuration of simply 2,8. Remember, all atoms form ions to obtain stable noble gas electron configurations. In general, that means 8 is great, but 2 will do for hydrogen. Question number 25 asks about the number of neutrons in the nucleus as a calcium atom becomes a calcium plus 2 ion, meaning the calcium ion atom loses 2 electrons to become an ion. When that occurs, nothing changes in the nucleus. We are not studying nuclear reactions, so everything will remain the same.